All right, stream 42. And it's going to be like a shorter stream because I only have like an hour before I have to head on out. I'm going to be trying to put semicolons in their place. So, meaning that not requiring semicolons to be at the end of a loop next statement. And as part of that, we could remove semicolon from most of the statement rules. So it's going to be grammar surgery. So I think most of it is in here, where we have a semicolon in almost every, not almost every, in a lot of the statement syntax, we have the semicolon. If it weren't for the fact that statements could also end in a right brace, then it would be a lot easier because I would just put semicolon between every statement. But yeah, we have right brace counts as a end of a statement too. Yeah, and then things like interp contain a semicolon in them, right? Right. You know what I could do? I could do a limited change. I could where is it for the for loop? This loop next, right? It's this loop next that is a problem because it leads to an unnatural looking for loop. It's this semicolon I want to get rid of. I can't do that because for example, that's in an increment statement. In an increment statement, it always has to end in a semicolon right there. Stop bouncing around. There we go. So one way I could solve this in order to remove that is I could do something like this where normally an increment statement would end in a semicolon, but we could have for this loop next, we could have a special kind of statement where I just repeat all of the grammar for statement and remove the semicolons. I could also take the opportunity to remove things that don't really like make sense in a for loop, like parsing, if statements, while loops and for loops. Yeah, bound statements don't make sense really. So what if like we just take these and make it a subset of statements? Like this. We could have a statement is that, or it's a statement 1 or something. So I just broke the grammar into the statement grammar into 2. I have to mark that public. Actually, do I need to mark that public? I'm wondering, if I only need to mark it public to have access to it from the testing? I'm not specifically testing a statement 1. maybe it's fine, right? What, that's ambiguous? Huh. All I did was break it up into two parts. Unexpected token. Okay, I have a syntax error. I think it's, is it this one? Yeah. Okay, not to worry. It's just a simple syntax error. Our tests are taking longer than a second to run. Okay, and then if I start to do stuff like this, where I can take off the semi and put it here, and then remove it from all these rules, right? And this should still work. Then what I can do is the loop next can be a statement one instead of a statement. Oh, you know what? One other thing I want to do is I want to drop the local statement declaration because it's actually unnecessary. First things first, though. So now that I've done that, let's give it a name like simple statement. And then for loop next, actually, hold on. Let's make another, actually, let's make another rule for simple statement. I was going to say like make a rule where the semicolon is optional, but you know, I'm not going to do that. I'll just force this to be not backwards compatible. So loop next will just be a simple statement. Yeah, I don't even need it to be a span statement because I don't think, actually, I think I do use span statement there. Hold on, span statement as a spanned, right? Yeah, okay, so I need like a spanned simple statement. For loop next. Because this might break some tests. In the for loop, it'll break the test because now uh, semicolon is not allowed in a simple statement in the context of a loop next. It's only allowed for and expected for a main statement. Yeah. Vector. Victor? What's your vector, Victor? Vector component by change vector. Here we go. So these probably have for loops in them. Yep, so that's not allowed anymore. Bad condition. Yep, you remove that. False string. Falsy string. And no, empty string. Yep, there we go. Remove that. Oh, test for true also needs to be fixed. Yep, fix that. Yep. A lot of tests in this module need to be fixed. Glad I'm able to remove the semicolons, so that's nice. Vector indexing. Vector indexing. Hey there, Russ Jr. Oh, thank you. I hope it was helpful. So I take it that you watched the introduction to Rust stuff? I bet if I went back and reviewed that, I might be cringe. It might be cringe for me. Because, we continue to learn things as we go, and I probably learned some stuff that, like, retrospectively looking at what I recorded, I'd be like, I could have taught this differently, or maybe some of it's even wrong. It was just a lot of work recording all that stuff. So, like, I wouldn't look forward to re-recording or editing that stuff again. Okay. Am I near the end of this? It seems like I am. Oh, what happened to my cursor in there? For loop. Oh, you haven't looked at the videos and you're learning Rust? Well, definitely check out the videos I have in there. There's a special playlist and everything. Introduction to Rust. Okay, so here we're removing the semicolon. But that means the range of the span is going to be different. Yeah, this is going to be going only up to 12. And this goes to from 14 to 16. Dr. Mulroy, how you doing? Or DeMulroy. For some reason, I thought it said .dr. It's DMMULRY. Cool. Passed all the tests. So did some grammar surgery just now. I had to fix a bunch of tests. So now all the statements in the language include a sub the rule called simple statement, and then the semicolon is extracted out of that simple statement. Simple statement are all the things that I felt like you might want to do in a for loop. Although things like break, I actually don't think that makes sense to do in the loop next for a for statement. And if we were to do it there, I'm actually not sure if it would operate correctly. I think it actually would break out of the outer loop if there was one. Return an error will do the right thing though. These are the things you'd normally do in a loop next. But yeah, so now loop next is just a span simple statement, which is a spans around a simple statement. So no semicolon needed. Okay, now I think I want to remove this local thing. I don't think it serves any purpose anymore. So zoop. Hello, enav23abc. I probably have a unit test for local that we need to delete now. I don't see one though. Maybe I never bothered to make one, so this will just work. What am I coding? I'm coding a programmable decoder. So for example, let's say you have this file. You might recognize it from the first few bytes, but it looks like this, or this to a computer. I'm making a tool that will allow you to specify what the format of that is. And if I can organize this right, and then we'll just run it like this: target How come it's not in my command history? Probably because I have it under time, right? Yes. Well, do it this way. Oh no, I can't show you. Oh, let's run the. No, this won't work either. Okay, I can't show you actually what the tool outputs for this because I'm in the middle of changing something. But imagine what it does is it will walk this data structure in order and assign meaning to these bytes. So it'll say, oh, well, the first byte is a header. What's a header? It's a string signature 24 bits long. There we go, GIF. If it's not GIF, it's an error. Next, you have a string version is 24 bits. So parses those, says, okay, that's the version number. Goes back, says logical screen is next. Logical screen starts with a descriptor that starts with the screen's width. So, okay, that's the width of the screen, which is, if I could get this to pop up correctly, 300. So 300 by 300 GIF file. And it goes through all the bytes of the file, matching everything up. Kind of like what Wireshark does with packets that it's captured at your network interface, right? It's like a smart hex editor showing bytes, and if you click on them, it shows you what it means. And this is just for fun in Rust. Well, it loads the GIF into a data tree that you can traverse in a scripting language or in a graphical user interface. So I plan to do both. I plan to kind of like Wireshark, have a GUI user interface that you can walk through the data. But I also want to be able to script this with Lua. So you might make a small Lua script that just extracts the width and the height of the image, right? Or maybe it just determines what kind of file it is, and GIF is just one possible thing. Kind of like how libmagic works in Linux. Today I'm working on the grammar for the language. I also have this little page here. So I wrote this years ago in C++. I'm porting it to Rust. 2/3 of the tool is the compiler for the language. So we're turning a program into an abstract syntax tree, right? If you want to learn more about compilers, lexers and parsers are the two parts of it. And I recommend the Dragon book, Compilers, Principles, Techniques, and Tools. It's the second edition now. It's actually closer to the 21st century of an edition. It's an old book. So I'm working on the parser right now, changing the grammar of the language. But once we compile those little programs, I run it through an ingestion library, which breaks down the binary data using that. Whenever you hear the term abstract syntax tree, think a version of a program written by a programmer, but with all the punctuation removed and the indentation turned into distance from the root of a data tree structure. So this would be the root node, and then these are the immediate children of that root node. Loop has its own children. This if has one child. So that's an abstract syntax tree. Because it's a tree, the punctuation is abstracted away, and it's the syntax of a language. So what I did first was I wanted to get rid of semicolons in the third part of a for loop, and so I did that by taking up some of the possible statements and making it a sub rule. And that sub rule, if you use it normally, you have to have a semicolon, but if it's in the third part of a for loop, you don't need a semicolon. And so it looks more natural. So like a for loop doesn't need to have a semicolon there, even though normally standalone, you'd have to do that. You'd have to have a semicolon there. If it's in a for loop, you don't have it anymore. And then what I was doing just now, where I broke my test and I can't run this, is I removed a syntax, a kind of syntax that's obsolete now, called the local declaration. So this test is testing it, and we can delete it. Yeah, so here's a little unit test, right? It's saying that we can assign to a local variable. So here's declaring a local variable. then parsing 8 bits as parse 8 bits as an unsigned integer and name it bar, and then copy the value of bar to X, right? So this doesn't work anymore because I deleted that from the language. So I don't need that anymore. Now the test will work. So that local variable declaration is now obsolete because the moment you assign to something that doesn't exist, it just assumes, oh, you mean that to be a local variable. So when this finishes, foo has a value determined by this return statement, which will be whatever we copied from bar. So it's this byte that's 42. It comes out as foo's value, right? But when we look up X, we don't find anything, right? It's none because X is a local variable. Local variables disappear when the function returns. Bar remains because we named the actual bits we parsed. And that's crucial because if we're going to make a structure that you can walk after you're done parsing, then we need to be able to remember, what the parts are. So bar is a part of foo. So bar, we need to be able to address it. Whenever you hear me talk about a part or a subcomponent, that's some subset of an overall format that almost always comes from the input bits, has a name, and it has a format of its own. So foo is a format. It's like a user-defined format. UI is a built-in format. X is not a part, doesn't have a format. It's just a local variable. All it has is a value. Values are assigned to parts through their format. So whatever unsigned integer that's 8 bits long we get from the input, then that is stored as a value. So input is just raw bytes. Values are interpretations of bytes. So 42 is an unsigned integer if we parse it with the UI format. If we were to parse this as a string instead of a unsigned integer, then it will be whatever ASCII code 42 is. I'm guessing that's like one of the number keys. But hopefully you guys get it. Test local. Apparently I have a test called local test local. Okay, so this entire module can be deleted because this doesn't apply anymore because we got rid of local statements completely. Completely obsolete. Goodbye. Nice knowing you, unit tests. Okay, so I have another test that uses local variables. So for using loop variable existing local, there we go. So if a local and then we assign it a value, we don't need to declare it as local anymore. And I have a test statement local. In the parser, so this one. Right, so this can go away completely. Deleted. Oh, I didn't see that in time, and now it says automod held at first smart detection expired and not posted to chat. So let me repost it. This is what you said, DM Molloy, and I have not read that. What's the interpreter book? Hold on. Writing an interpreter in Go? Well, that sounds fun, but I haven't read it. So what do they learn? They learn about a lexer, a parser, and episode syntax tree. Hey, why do those sound familiar? Well, maybe it's because I have them right here. Lexer, parser, abstract syntax tree. Pratt parsing technique. Recursive descent parser. I think that's the kind of parser I have, right? 200 pages? That's pretty cool. The monkey programming language. Huh. Function literals. Cool. Let me give you a point for that. Now you have a useless internet point. You have joined the 1% of people in chat in my stream that actually have more than 0 points. That's cool. I like it. And that's an easy link to remember if I wanted to find that back. Yeah, what was that? Interpreter book? Oh yeah, interpreterbook.com. Okay, we did this. It is done. Do I have something to say get rid of local? I never made a to-do item for it. I do have to update the GIF grammar because this has local in it, right? So if I try to run my parser now, we'll discover where it is because it prints out syntax errors. Oh, I can also remove local as being a reserved word. It's already 8 o'clock almost. Time flies. Time flies, especially while you're waiting for the compiler. Well, actually, it's the opposite, right? Oh, it parses so I don't have any locals? Huh. I must have already gotten rid of them all. Okay. Well, that's cool. We could parse GIF files still. So what was I going to do? I was going to remove local from being a token in the lexer. So output, right? Actually, token, we can remove it from token completely. So local is no longer a reserved word, which means in output, we have to remove it from the lexer. Deleted. And that's up here, right? Local. So here's a peek at the lexer implementation using logos crate. Logos, ridiculously fast lexers. That's how we do white space. This is how we do reserved words with token. Regexes with callbacks to do more advanced parsing of like anything that is pattern based. And I abstract away the fact that we're using logos by having a third party, so to speak, library called token, where it has no dependencies. We do a translation from one to the other so that the parser doesn't depend on logos. Where am I located? Southern California. So it's 7:57 a.m. here. Yeah, so this is the EU friendly streaming time for me. When I stream in my evening, it's very EU unfriendly, and my friends in the EU always complain, rightly so. Why am I streaming at 3 in the morning, right? Okay, so I removed that. There are a bunch of errors though, because we have test cases for this. So let's remove the test case. I was surprised to see so many errors though. Well, that's in the grammar. Okay, so in the grammar, I guess I still have local. That's not. Oh, that's the new grammar I added last night. It's this one that I need to delete, right? That line. If I build now, those errors should go away. Yeah, so a lot of people have found this stream because I'm a moderator in Adam's stream, and he has a lot of friends in the EU because it's also an EU friendly time that he used to stream in and probably will again. Up, Togglebit, how are you? How was the rest of your stream? I was sort of I pop into your stream if you're actually going while I'm getting ready for mine. You did find this stream, and hey, I just got my stuff to run again, so I can actually show you what I'm able to do now. Except, okay, actually, while that's compiling, really brief intro for those who haven't seen it. So I'm making a general purpose programmable decoder. So given like some kind of raw bytes, my end goal is to make like a smart hex editor that I can tell the editor what the format of those bytes are, and then next to the raw bytes there'll be like a nice tree structure showing the structure of this. And if I click a byte, it would say, oh well, that's the 30-second entry in the palette for the image. So, and yeah, I actually have to pipe that to less. So this is a GIF file, right? And this is its overall structure. We describe it in a domain-specific language that I came up with. So the tool has a compiler for this. It turns it into an abstract syntax tree. It does an in-order traversal, which means, starting from the top, it says, well, the structure of a GIF starts with the header. The header starts with a signature and a version. There's a signature, there's the version. It does some checks to make sure that it's valid. And that's the output. You can see that it starts at offset 0, it's 3 bytes long, signature. Offset 3 bytes long, version. The overall GIF is 6 bytes long. It has the version as the value because of the return statement. And on and on and on, all the way down to the trailer, which has a label in it, which has to be 3B or 59 decimal. So there are 61 frames total. In the spec, they call it data, but it's really a frame. Actually, I guess it could be a frame or it could be an extension. So the end goal is to make like a user interface or something scripted that is, like I said, like a smart editor, like Wireshark could be an example. Drop a bunch of packets in there and you can see them in their raw form, or you can see how they're interpreted. Today I'm just kind of cleaning up the grammar of the language, removing like the vestigial parts and fixing some of the warts. You must go snack and parent. Okay, see you toggle bit. Does it make sense that the DSL is more similar to eBNF so that it's simple to adopt from a white paper? I had a lot of inspiration in this language. One of the things that inspired me was how MPEG-4 is specified. They chose a language that's kind of like C, but has annotations similar to this to mark up things that are hard to describe in C, like fixed width fields. And I also kind of reduced it to a minimum, and I want it to be readable as like a structure. It looks like a structure, right? It says a GIF starts with the header, ends with the trailer. But it also has C-like constructs, like if statements, loops, break statements, so you can break out of loops. So it's sort of evolved to be a mix between like declarative style and imperative. The language looks good. Yeah, so I didn't completely invent this from nothing. If you look up the MPEG-4 standards, the way those define their data structures is very similar. And this got a lot of inspiration from it. I added a few things that made sense. Like this is an interpretation map. This says if the string is 87A, then the interpretation of the data is 1987, because that's what it actually means. It's like the 1987 version of the spec, and so on. So this is meant to be like a clue for a graphical user interface to, like, if you hover over the version, it would say, well, that means 1987. It could also be used for like if you have a bit pattern in a file that maps to an enumerated type, you could actually encode what each of the variants means. But it is sort of optional because I could write this with a bunch of if statements also. So this is not going to be a very long stream because I have to go in like half an hour. But I kind of want to make sure that there's no vestigial parts, like no parts, no grammar rules that are like unnecessary anymore. It all looks good to me. I wonder if I could combine increment and decrement. Because they operate the same way. Oh, so I should explain what I'm looking at. This is the parser generator. So the tool is really in three parts. Part one, lexer. Part two, parser. Part three, ingestion. Lexer and parser, that's a compiler. So you're turning an input program into an abstract syntax tree. It's broken up into two parts traditionally because they're completely different techniques. So a lexer is really just a complicated set of regular expressions to turn the input text into tokens. So GIF is one token, but a left curly brace is also one token. Parser is assigning meaning to these with rules. So it says that this is a format, this is a statement, this is a loop, this is a conditional, right? This is another statement. And I use two crates for this. So for the lexer, I use logos, and that looks like this, where you define an enum and then you mark it up heavily with attribute macros. And the derived logos is the main one. That's deriving the lexer. The attributes say like, what's your white space? What are your reserved words? What are the regular expressions for matching your literals? Things like that, right? And then I use Lollipop for the parser. Lollipop is a Rust code generator using BNF or Bacchus North-Form grammar rules. So overall formats, it's whenever we see a token sequence that matches a rule, we do a reduction. So whenever we see a formats and then an error, we'll reduce it to an error. If we see formats and then another format, we'll combine those formats together into the hash map and return it. And they can be recursive, and that's how we make chains. So a list of statements or a list of formats, it's like the format so far and then the next one. And so it's left associative. Could also do it right associative, and actually I do that in some places now in order to get the comma, optional comma to be on the right instead of the left. So like did this yesterday, right? Yeah, arguments. So it's now right. It's right associative. See, the chain rule is on the right, and then that allows arguments can match the empty rule. So you can have just one argument, and then a comma, and then nothing. So trailing comma. If you do the left associative rule, you end up with a weird case where you can have a prefix comma, and that's legal, but you can't have a trailing comma. The downside of this is since it's right associative, we're building from the right to the left. If I were to use vector push, we'd have our list of arguments in backwards order. So I have to do this insert, which I don't quite like because it's not as efficient. We talked about using a vectq instead. What I would really like to have is a vector that can grow in reverse order, like a stack, but then at the end be able to use it in forward order. Lexer cares about the curlies. The parser tosses it, turns it into a tree. The parser never even sees the curly braces. No, that's not true. It does. The lexer cares about every character. The parser only cares about tokens. So what the lexer sees as individual characters, the parser sees as just one token. When a token is a single character, it kind of passes through the lexer as is. It just gets a new name. So in the grammar, we'll see things like L brace, that's just a name for left brace, right? One of these. It's when the rule gets reduced that the braces go away. So in the end, we just get a loop statement. And the fact that it had the reserved word loop and then left brace and a right brace, that all goes away. The only thing we retain are the statements in the middle. So in the end, the abstract syntax tree is built from these constructors. So when the whole thing gets reduced, things that don't go into these constructors get lost. So the reserved word gets lost, all the punctuation gets lost. Textbook as in the approach, yeah. So the approach you learn from the Dragon book or from that interpreters.com, I'm using the same approach. So it's a classical shift reduce parser generator. We're shifting in these symbols until it matches a rule, and then we do a reduction. We would reduce this to a statement because we're in the statement grammar. All right. I think I'm done with this. So I got some extra time before I got to go to work. What should I work on? Something that I need to do? All the things that say consider having the bot, that's for the streams bot, and I don't want to work on that today. Consider allowing locals marked in some way to be saved as parts of a component. That's an interesting one. I had the idea, I'm using the plus character and the minus character for like to assign extra meaning. So a plus character in front of a format means that it's a look ahead format. We're going to rewind the stream when we're done. It also means that the name we give it, since we're not keeping the bits around, it's really a local variable. It just temporarily has a part of GIF, but only for using conditionals. And then really those 8 bits are part of the data block. So that's like these little decorators. So another kind of decorator I was considering is for local variables to be saved as part of a component. Normally they're not saved. So an example of a local variable, let's find one. Really don't have too many here. Oh, I guess down at the bottom. Oh, not even here do we have a whole lot of locals. I guess these look aheads, maybe. I mean, this next, I guess. If we wanted to remember at every stage that next, what the value of next was, I would have to mark this up in a certain way. So, like, maybe it would be like a bang character or something would mean that I want to save it. Then it would be, it would say, oh, we actually need to save this. And so when we print out GIF, it would actually print out the next value of every loop. Whereas that, it wouldn't. A huge is LSP in the space. Anyone who works in telecom would love this. Well, it kind of already exists in the form of, I think in Wireshark, I think they call them data dissectors, I think. That those are pretty easy to make. And those plug in already pretty well into that. I'm just doing this for fun, and I don't think it's really that new. It's maybe it's a niche thing, right? So I think if you worked in the telecom field, you probably would say, oh, well, yeah, there are a couple things that already do that. I don't know, but maybe I'm wrong. Maybe this is novel and I should market it. Yeah, I'm only really using local variables for look aheads. Okay, what would the syntax look like if, so locals can be because they're ignored or look aheads, and that's with the prefix character. I'm thinking it should go with the name. So like maybe a plus there. The only thing is that there are two pluses. Isn't that going to look confusing? I don't know. Actually, want to know a secret? 20 years ago, I actually made this for a company, and they actually marketed it briefly, but I don't think it caught on because they didn't like sell it very well. But it was used quite a lot internally. The thing that I ran into was people who got the tool didn't want to bother having to learn the language and program it because they just wanted the tool to already understand the formats that they cared about. So they would just ask me, "Hey, I want to use your tool, but I want to use it for this format. Could you write the format for me?" I'd be like, I designed this so that you could do that, but okay. This is really a tool made by programmers, designed for programmers. So when you think about it, if you have to write a program to use the tool, it's not going to be as attractive as a tool that already understands the formats. Yeah, so in addition to the tool, I'd have to like build up a repository of formats. Slay the dragon then. So yeah, I really like that tool, and so that was years ago. So nowadays, like I remember making that. I can make it again, right, and maybe make it better this time. So I'd like to think that this is an improvement over what I had. I don't think it was 20 years ago. I think it was more like 12, maybe 10. Okay, so I guess I can just make a contrived example of this. So do I have a test for, and this would be in the ingestion library for locals? No, but I had part, right? That's kind of close. I really should have a test for locals. Unless it's open source and people just code a bunch of formats. Yeah, it would have to be a niche thing like this might not catch on very well in open source. It might be like have like a spark of popularity and then kind of fizzle out. Do you recommend Rust for writing a compiler? I mean, it's not bad because there are crates like Lollipop and Logos that you just string those together and you have a compiler. So the heavy lifting is already done. As is more and more the case these days, you don't have to write it from scratch in Rust. You can leverage these crates that are pretty well designed. I can say that the compiler I made is faster than the C++ version, which was nice. I was looking at Flame Graph yesterday and finding obvious, easy optimizations. And even before I started looking at this, it was already faster than the C++ version. So I was happy about that. I think Rust tends to lend itself for fast code because it encourages um, borrowing and discourages copying or discourages cloning. What memory allocation it does is sort of you have to do a clone, but if you do like an address of your sharing, I think that tends to it's put good and bad. It tends to drive people towards not doing extra memory allocation and all the pitfalls of that. But the disadvantage is that you have more struggle with your lifetimes of your borrows because of the safety checks of the language. You have to worry about lifetimes and stuff like that. But once you get it to work, you don't do as much copying around as you do traditionally, and so your code is actually faster because of it. Um, okay, let's just make a new. Did I just copy this? Why don't I just copy this? Not that, this. Local. Tests. Mod local. Okay, so we're gonna have like saved local. So that means we'd have like x equals 42, and then I put a plus in front. And then we'll have another test where it's not saved. So let foo equal that. And then we'd be able to assert that data value unsigned integer 42 equals foo.keyed children.get x unwrap dot value. So this is going to fail right now because for one, it's a syntax error to say that. And even if it wasn't, this is implicitly a local right now. Locals aren't saved, so you wouldn't be able to get the value out unless you did a return. So unexpected token assign. So it saw the plus x and then it saw the equals and it's like, I don't expect that. I'm guessing it's because plus is valid because it could be an increment statement. So here's where we get to adjust our grammar. I have to be careful here because the way this works is an assignment statement is a reference, but reference is used in other places. All of these are fine to put a plus in front. In fact, it's going to look weird because increment will be plus, plus, plus. Decrement will be minus, minus, plus. Which makes me think I should put the plus on the other side of the identifier. Then it might look a little nicer. So maybe it would be x plus. But then we can't tell it from us accumulation. So, or maybe we use the bang character. But then we can't tell the difference between that and not equal. So maybe I just accept that little quirk that we might have minus minus x. Actually, we wouldn't do that anyway because increment and decrement kind of only work if the variable already exists. So I think this is fine. So anyway, ref, it can be reused, right? As an expression. And then it becomes a little bit ambiguous. So maybe I don't put it in the reference syntax. But that I would put it in front, I guess. So there might be an optional. So this would be preserve. Optional plus. So let's try to do it this way. Actually, then really it only makes sense for a couple contexts. Assignment, accumulation. Actually, let's just limit it to assignment for now. And we need to define optional plus. Bool. It's either nothing, which goes to false, or plus, which goes to true. Let's see if this compiles at all. Minus minus plus is starting to look like brainf. Yeah. Links for the commands become invalid due to the brackets, by the way. The links for the commands. They work for me when I click them. Oh, you're right. Okay, thank you. They aren't working. They were working originally for me. So you deserve some points, Ron Dev. I'll give you 3 points for that. Now you have 4 total. So that means I have to fix these. Edit com logos. I guess what we'll do is just remove the those. 4 is a lot. And I have to fix the lollipop one, right? Thank you for that. So we'll fix it. Hopefully I don't have any other broken commands like that. Only have like 5 minutes. Oh, okay, so that made my grammar ambiguous. Well, what if I use another character in front? Bang. We have to actually add it to the tokens now. Oh, no, we have a bang. It's a not, right? Not. Nope, doesn't like that either. Okay, well, how about... Yeah, I didn't need that. Let's keep the plus, but put it after. It might not look like an accumulate if there's space between it. This might be okay. Okay, so it's okay with that. So then it would look like plus. As long as there's a white space there. I don't like it though because it looks like a plus equal. Could I have like a hat in front maybe? What other symbols might we use? Dollar sign? Don't use dollar sign yet. It looks like pearl to me. I can put it in and then change this later, right? Yeah, it's just, we want to get it in. So let's just keep that. So this will parse now, but it won't actually work because we're actually not using the flag yet. So it panics on unwrapping X because X isn't preserved. So it's preserved local. Okay, so then I have to actually preserve it. So back in the grammar, I have to do something with this flag, right? So yeah, I suppose the easiest thing would be to add it to assignment. So that means assignment in statement in AST has to have a preserve flag on it. Right here. Which breaks a bunch of stuff, right? So we have preserve. Let's put something in here. We say if preserve else nothing. Okay. The errors actually bring me exactly where I need to go. Serve bool. Actually, I think I'll need to dereference that. Okay, so I think what we do, I think all I really need to do here is say if preserve, then remove it from the from the list of locals, so it'll actually get saved. So self.locals.remove the name. That's that LHS, right? Oh, evaluate. We don't get the name back. No, well, yeah. Actually, problem is, what if we do something? This reminds me, what if we do something like this? What if we did like x equals some array, and then we do x0? Technically, that says to preserve one element of x, right? Does it preserve the whole array? I think I'll just keep it simple and say it's going to use the first ID in LHS. So 0.id. Wait a minute. 0.first dot unwrap, because we wouldn't have gotten one without this, right? Or expect dot ID. Expect reference to start with an identifier. Okay, so I think that should work. Not 100% happy with it though. Well, that's interesting. Now it sees errors. Is that because it's in a test? Okay, yeah. Actually, then here's my opportunity to actually add that. So it's assignment with preserve. Assignment with preserve, or preserving assignment. Would be token plus and then assign. true, whereas the other one is false. Comma. I'll have to think about the grammar, because that looks too much like an assignment. It like depends on there being a white space there, and I kind of don't like that. You know, the other way I could do it is this. Then it looks like a Pascal assignment. What if we try that? So it would be then optional colon. Actually, I have optional colon, don't I? No, I don't. Oh, it's ambiguous. Dang it. Bummer. Okay, well, it's plus for now until I can have more time to look at this. Well, this is going to fail until I do that. Okay, I gotta run and get ready for work, so I gotta rate someone else. And on the way to work, I'll probably think about this, and I'll probably come up with some ideas in the car. So again, the whole point of this is that I want to mark a local to be preserved so that we can actually find it in the output composition, whereas normally local variables are stripped. And you know, an alternative to this would be like save X. If I made like save a reserved word, I could even put it in front, save X equals that. You know, another alternative would be I just invent a new token called preserved assignment, or like, you know, the old Pascal assignment. So these are all ideas of things I might do. Right now it's sort of weak in that it looks like if you just move the space around or didn't have the space, it's a different kind of statement entirely. It's an accumulate statement. All right, anyway, I gotta go. Thanks everybody for watching. Let's try to keep the momentum. We'll go raid Tim. Tim's working on his own games in C++. So, you know, we're not biased for or against Rust or C++. We're all programmers, right? Space Cadet Commander. Nice emote you got there. All right. See you guys later. Take it easy. Bye.